Let's today discuss about timers and how to do programming in 8051 microcontroller. In 8051 we have two timers and they are timer 0 and timer 1. Timer can be operated even as a counter. There is small difference between a timer and a counter. When it is being operated with internal clock, we call it as timer. When it is operated by external, it is called counter. For an example, from any sensors, you will get an input. For example, we say when you go for a car parking, when a car arrives, then it will be incremented. See, timers will be incremented at a regular interval, whereas counters will not be incremented at a regular intervals. Half an hour a car can come, then for an hour you may not get a car, or within a 5 minutes you may get a 4 or 5 cars. So what we conclude is a timers will work on regular interval, whereas counter will not work on regular interval. Okay, so in case of 8051 we have timer 0 and timer 1. Both are 16-bit wide. So 16-bit wide means you can load the timer with 16-bit. Your processor is an 8-bit, but you can load a 16-bit, which means timer can work from 4 zeros to FFF. So that is what we say. To load this, I should have a lower order 8-bit and an higher order 8-bit. Registers involved in timers. See, whenever a timer has been brought inside the microcontroller, there should be a person called to tell about the modes of operation of that particular timer, whether you are going to use in what mode, mode 0, mode 1, mode 2 and mode 3. There are so many modes, so that we call it as TMOD register, that is timer mode setting register. Then since we have told there are two timers, so for each timer you should have a lower order 8-bit and higher order 8-bit. Note that this is 0, not O. So timer lower order 0, timer higher order 0, that is for timer 0, and similarly for timer 1. Then there is a register called TCON, timer control. See, there is a difference between mode and control. From the word itself it is very clear. Mode, in which mode you are going to operate, we call it as TMOD. Whether to start, stop, check the condition of whether timer is over, that all will come under the register called TCON. So now let us start with the first register, saying it as TL0, TL1, TH0, TH1. Okay, so you can see it is an 16-bit register. 8-bit is been split up. So whenever you want timer, you have to load this fellow. So what is the content loaded? From that value it will start. Please listen, timer is an up counter. So if you load a value, it will be incremented by 1, and when it reaches FF on the next clock, it will be changed as 000. So it means it is overflowing. So overflow flag will be set, and we will come to a conclusion that timer is over. So let us see TMOD register. The both timer 0 and timer 1 use the same register. So there is only one TMOD register, and that TMOD register is used by both timer 0 and timer 1. So lower order 4-bit is for timer 0, higher order 4-bit is for timer 1. Okay, so let us see. TMOD you can split up into 2, 0, 1, 2, 3. It is for timer 0. 4, 5, 6, 7 bit is for timer 1. So in which this 0 and 1 will tell about mode of operation. Similarly 4 and 5 will tell about the mode of operation of timer 1. Then C bar T and 0 as well as the C bar T1, whether it will say you are going to operate in counter or timer. I have already told, when it is timer it is internal clock, when it is counter it is external. Okay, then comes the person called gate 0 and gate 1. This is for timer 0 and this is for timer 1. The gate is nothing but, see, whenever gate is open, the timer will continue. Whenever the gate is closed, timer will stop. So start stop is taken care by gate, and C/T tells whether it is timer or counter. M0 and M1 is for mode selection. So this is very easy. With the help of TMOD, we are going to select the mode, we have to select the counter or timer, we have to select start or stop. So that is being clearly told here. So okay, gate. What is the purpose of gate? So a gate is nothing but it is similar to the gate of the house. Whenever the gate is open, you can come in or go out. When the gate is closed, temporarily it is been stopped. You can stand and wait, and once the gate is open, you can go. So to do start and stopping by either software or hardware control. In using software to start and stop the timer, where gate should be kept in 0, the start and stop of the timer are controlled by the way of software by TR. That is, you have this particular bit in TCON timer control. So when you controlling by software, there a control TCON will have this 2 bit location. By setting this, you can start. Whereas when you go for hardware, you should have an external source that you will use with for turning on, turning off. So now let us see TCON. See TCON bit number 8, bit number 7, bit number 6, bit number 5 and bit number 4 alone involved in timer. Remaining are interrupts. Okay, so based upon that, you have to use which interrupt you are going to use. See, for an example, I am going to use timer. This bit should be set. If it is timer 1, this bit should be set. This is for turning on the interrupt by timer. See, timer is also one of the interrupt. So your main program will start the timer work and continue its own work. Once the timer work is completed, processor will be interrupted. So timer comes under interrupt. So when you want to use it, you want to enable the interrupt, then only you can use. So okay, then to start by software, we told that there are 2 bit, TR0 and TR1. So when you set this bit, timer will start. Once the timer start, it will go on increment by internal clock or external way. Then once it overflow, this particular flag will be set. So what you will do, you will set this 2 bit and wait for this 2 bit to be set. I repeat, whenever you set the bit TR0 or TR1, timer will start. Then you have to only monitor the bit TF0 or TF1. Once this is set, we will come to a conclusion, timer work is completed. Okay, so we told there are mode 0, mode 1, mode 2, mode 3. You have to notice the only thing variation is the how much bit you are going to load in your timer value. So in mode 0 you can load only 13 bit. In mode 1 you can load 16 bit. So full range is being used in mode 1. And mode 2 is called as 8 bit auto reload, which means you don't want to clear it and you don't want to put it in a loop. The timer mode 2 itself will automatically take care. So it will repeatedly generate ones and zeros, that is called as auto reload. And the mode 3 is an 8 bit. So mode 0 is 13 bit, mode 1 is 16 bit, mode 2 is 8 bit auto reload, and mode 3 is 8 bit mode. Now let us start with the mode 0. So in mode 0 I have told the 13 bit. Only caution you have to remember is higher order is fully 8 bit and lower order only 5 bit is being used. Don't reversely think that is lower order full and higher order 5 bit. It is not in that case. Lower order is 5 bit and higher order is 8 bit. Okay, so that is for mode 0. And when you come for mode 1, it is 16 bit we have told. So you will use total 8 bit lower order and 8 bit higher order. In mode 2 we have told it is auto reload. So you will have the person stored in higher order. So what you have to do is you have to tell me the value of the counter bar timer, and you have to load it only in the higher order. From the higher order, automatically it will be passed to lower order. Then for every clock this will be incremented. Once this gets overflow, it will indicate your overflow bit, and automatically again this will be reset to 0 and the content will be transferred from your higher order. Okay. Then comes mode 3. Mode 3 is small thing you have to understand here, that is both your flags, that is overflow flag of timer 0 and overflow flag of timer 1, it is being done with an help of only with your 8-bit content, that is also only in the content of timer 0. Timer 1 is not being used here, only timer 0 is being used, whereas flag of both timer 0 and timer 1 are being used. So now let us start with an writing program in timer. So first program what we are going to write is generate a square wave of 50% duty cycle, which means T on and T off are same. Okay, on port P1.5. So there is a port called P1 in which 5th bit you have to generate this square wave. Okay, and they are specifying you are going to do with timer 0. I repeat, the thing you have to note, you have to generate a square wave of 50% duty cycle, which means T on and T off are equal. The output should be coming out in pin number P1, port 1.5th bit, and the timer which you are going to use is timer 0. So what is the step to be followed is, first you have to load a TMOD. Okay, for an example, I am loading it as FF, F2H is loaded in TH0 and TL0, TH0 and TL0. Then we will toggle for high and low position of the pulse, then call for delay. Call for delay is nothing but timer start and checking for overflow. So timer 0 is started by setting TR0. I told in a control TCON you have this particular bit. By setting this bit to 1, timer will start its work. So when you want to start your timer, so before starting the timer I should load the value and I will tell the TMOD. So TMOD work case is here. We have to specify timer 0 that have been done using TMOD, that the value to be loaded is loaded in, when you say timer 0, you have to load it in timer 0, TH0 and TL0. Then toggle pin I can do with the help of command. So first time if it is 1, after completing the timer it will become 0. Then again it will be doing its timer, then again it will be set as 1. So when you set the bit called TR0, timer will start. So it will become, say I have loaded F2, so it will become F3, F4, F5, F6, F7, F8, F9, FA, FB and goes on till FF. On more clock it rolls to 0, rising the timer flag TF0. Okay, so very clear. Load the TMOD, then you have to tell the value to be loaded, then you have to toggle, then you have to come to delay. In delay it is nothing but you will turn on timer. So once timer is turned on, we have to monitor the person called TF0. When the TF0 is 1, we will come out saying the timer is over, that we will stop and clear TR0. So you have to clear your TR0. So TR0 will be brought to 0, again come out. You will set some, give the value, again you will set this and you will proceed. So program, please listen here. So be clear, that is MOV, so that is move TMOD, 01. So when you see hash, we all know that is followed by data. So here 01 I am going. So timer TMOD is split up into 2. I think you remember what I have told. Lower order 4-bit is for timer 0, higher order is for timer 1. So timer 0, so lower order. So that is why the lower order it is 01. It is not 10, it is 01. If you put here 10, it will become timer 1. Okay, next you have to load the value. I am loading lower order, then I am loading higher order. CPL is nothing but complement. So if it is 1, it will become 0, 1, or if it is 0, it will become 1. Then call delay. So initial step I have done. So now I can start my timer. So I will set TR0. Once I set this TR0, your timer will start incrementing. Then my work is to go and monitor this particular overflow. So JNB, if it is not been set, this will stand in the same line. This condition will fail when TF0 becomes 1. So 1 is becomes 0, it will go to the next line. So automatically clear TR0, clear TF1 and return. So again I will come out. So this is the program. So let us simulate this. To this simulate, you should have an simulating software. It is Pakka when you want, very easy to understand and very easy to install. Just if you have Java in your system, and just this is a small file, just by clicking this will open. Please see here how user friendly it's. Your timer values here, okay, all registers 0 to C7 general purpose registers are there, all special function registers are there. Then this is the data memory location they are specifying. All ports is being kept here. So our task is to copy these lines, paste it here. Okay, so if you are doing any wrong, automatically it will be indicated. See, for example, instead of putting 0, if I am putting O, and if I am asking to run, it will stand in the line and say it is wrong. So okay, so to some extent you can identify. So first of all I am moving TMOD, so I can ask it to run. Okay, once I run this, see it is starting, time is indicated here. Now instruction executed is being told here. Okay, for our case, please listen, our port is P1, bit number 5. So bit number 5 is our case. Now presently it is in 0. So okay, again it is being turned as 1. So it will be toggled for ones and zeros. So please you can note here, it is now 1, again it will become 0. So I will explain again. You are loading your TMOD, then once you are loading a TMOD, you are telling the lower order, higher order, then I am complementing. First if it is 1, it will become 0, or if it is 0, it will become 1. Then it will call delay. Delay is nothing but you are turning on your timer. So you will jump there, come here, start the timer, then you wait for flag is whether setting or not, then you will come out. So you will repeat this and you will toggle this particular pin. Okay, even like LED, some lighting way I can say this is 0th bit and this is 7th bit. I am tagging 5th bit, so 5th bit is being toggled here. Okay, when you connect 7 segment, usually 7 segment is connected through port, so that particular bit is, you can see that bit alone is glowing. So with the help of this simulating software I can simulate and see. Okay, so that is the first program. Now let us move on to second program. What is been asked here is write a program to generate a time delay of 5 milliseconds. Last time they didn't specify the time, so I have loaded a value of my own choice, whereas now the question is they have told that you generate for 5 milliseconds. It is a huge value for microcontroller because they are working on nanosecond. Okay, and now I am simply changing it as to port 2. So output I want in across port 2, that is third bit. Okay, bit number 3. Now same timer 0 I am asking to do, and I am asking you to set the crystal frequency as 11.05. So what is the first step? You have to know what is the time taken for a single instruction to be executed. So it is nothing but 1 divided by frequency, which is around 1.085 microsecond or 1 microsecond we can take it. So this means that out of many 1.0 intervals we must make 5 milliseconds. So now we have to identify how many times. So what we can do, we need is 5 milliseconds divided by 1.08. So around 4608 clock is required. See, I told it is an up counter. So what is the maximum value? F. 4F is nothing but 65,536. So that minus what I required is 4608. Then only I will get the remaining value, since it is an up counter. It is 60928. This again is a decimal converted into hexa. So finally I am getting it as EE00. So this I have to load. Okay, so that way we will run here. Clear, we have done. So it will, one time it will be 1 and one time it will be 0. Now you have to set the mod. Again I have told only it is timer 0, so you are using timer 0 to turn on. Then I think what we have got is lower order is 0, higher order we have got EE. So I am loading lower order as 00, higher order I am loading it as EE. Okay, then set the particular bit. So I am setting the bit, so that particular pin will become 1. Then I will start my timer work. So timer I am starting. So once if this TR bit is 1, automatically it will start incrementing. Then it will continue till your overflow flag is been set. Till the overflow flag is not been set, this will revolve in the same line. Once this case, it will come out. Here I have set it. Now I am clearing it. So one of that pin in port will become 0. Then I have to clear my start of timer. Then I have to clear my flag and then repeat. So okay. So this is for your case. Now let us even simulate this and try to see, but see, it takes very long time. So till that time we cannot wait. Just we will see whether the program is starting or not. Okay, you cannot sit and monitor because this is a big value. So now I have deleted, so I will put the new program. So see, it takes long time I have told, so just we will run it. So once it start running, initially we are setting this, so automatically that particular pin will be 1. Then your timer starts its work. See, now we can see here higher order is EE, lower order will be go on incrementing for the clock. I have told here, when you want, if you are asked to do with some other crystal, you can change the crystal value here. I have put in 11.05, so it has been told in some, so that I am putting that value here. If they say 12 megahertz, that in 12 megahertz you can put it as 12 here. See, it is go on incremented, so EE become now EF. So at the next, what you will do after this FF, it will increment. So after E it is F, so it become F0. Okay, now are you able to see it become F0? So it will go on do till it becomes FF. So okay, so it will take you long time. Just we will see here now itself how many milliseconds, microseconds, 700 something it is microsecond. Number of instruction which is executed is around 357. So it will go on increase to your required level. It will come. See, this is in micro, then it will come in milli, then you want 5 milliseconds. Okay, so you can note down here. So at home, if you do this, you can sit and see here till it reaches a value of 5 milliseconds. This will run. We have calculated such that, so this now it become 1 millisecond. So you have to wait for remaining 4 milliseconds. Once this become 5 milliseconds, automatically the value which you have set as 1 will become 0. So task is been completed. You can say that your program will generate a time delay of 5 milliseconds. Okay, now let us stop this. We have understood how to do. Okay, so that is what we need. We have to load it, wait there, and you want to check it, and you have to, we will get it. Okay, thank you. So next, just we will see one more program. Why I am saying this is this, why I am taking this number is, this number is required for us 50 Hz. So what I am saying is, write a program to generate square wave of 50 Hz frequency in a particular pin number P2.3. So when you say 50 Hz, it is 20 milliseconds, and 20 milliseconds you want off for 10 milliseconds and on for another 10 milliseconds. So 10 milliseconds you need. So that program, previous program was only for 5 milliseconds, now it is for 10 milliseconds. Only difference here is timer 1 is being asked, not timer 0. So automatically TMOD value will change. Okay, so now please listen there. I need 10 milliseconds, so 1 is 1.9. So the value which I am getting is 9216. This 9216 should be subtracted with the full value. This is FFF. See, this we are doing only because it is an up counter. Okay, I am getting it as 563200 is a decimal number converted into hexa. I will get it as DC00. So now you are twice the value you are asking to run with respect to the previous program, which is 5 milliseconds, whereas this is 10 milliseconds. Okay, so lower order is 00, higher order you will load it as this particular value. So TMOD, now you have to listen very carefully that till previous program it is timer 0, now it is timer 1. Okay, so TMOD value will change. Then you have to load your both the person, then you have to start. TR bit is set, so timer will start. Continue on this line till your overflow flag is set. Once the flag is set, you come out clear. In here you have set it, you are clear. Then clear your flag alone, then yes jump again. So automatically you will come to this location. Then you will load. Don't want to specify mode. One time if you tell the mode, that is more than sufficient. Okay. So even we can see whether this program is running. I am again repeating, you cannot continue till it is completion because it may take huge time. See, our program has come to 2 milliseconds. Okay, so pass it, then try to erase this. This is not allowing because it is not been saved. So you have to say that I don't want, then only you can erase it. So erase it, and then paste our new program. This is with the timer 1 is taking place. So you can visualize. See here, initially it was with the timer 0, now it will move with the timer 1. So previously you were seeing this value is being incremented, now this value is being incremented. So instead of timer 0, now timer 1 is being used. Okay, that particular bit will be set. So that is, we all know, P2.3 will be set, but this will change only after it reaches 10 milliseconds. Okay, so it takes very huge time. The thing you have to notice, it has been incremented here. So it will go on. See, it is DD. So it will, D will get over, then E will get over, then only you will get F. So once you get value is being reached, obviously that particular bit will be reset. Okay, so that is what the simulating software helps us to understand better. So by using the simulator softwares, we can understand it better. Okay, so regarding this, if you have any doubts, you can contact me through this mail ID, or you can even call to my number so that I can help you. Okay, thank you.